Hello everyone, this is your second session of chapter number 4, data structures. In this session we are going to study about the representation of one-dimensional array in memory. Representation of one-dimensional array in memory. Suppose I am storing 10, 20, 30, 40 and 50 in an array. So the name of the array is A. So the location, always it starts from 0, A of 4. Hence the last element location is n minus 1. So this is called as lower bound of an array and this is called as the upper bound of an array. So the address of first element is 1000, 1001, 1002, 1003 and 1004. So here the elements are stored in a contiguous memory location. The continuous memory location. So now I want to find the address of the element, that is 40. I want to find the address of this element. So how to find the address of an element? So using the formula we can find the address of an element. So the formula is location of A of P is equal to base of A plus W of P minus LB. So here location is nothing but the location of an element. So here P is the position of the element. The position of the element is 3. So here the value of P is 3. Next, base of A. What is base address? The address of the first element of the array is called as base address. The address of the first element of an array is called as base address. Now the value of base of A is equal to how much? 1000. Next, what is the value of W? W is nothing but the word per memory cell. So how much we are going to store here? 1 per memory cell. So 1 element per memory cell. Hence the value of W is 1. Next, what is P? P is nothing but the location of the element. What is the location of the element? So the location of the element is 3. Hence the value of P is 3. Next, what is the value of lower bound here? The value of lower bound is 0. Hence the value is 0. Now substitute these values in this formula. So location of A of, what is the value of P? 3 is equal to, what is the value of base of A? Base of A is 1000 plus value of W is 1, then value of P is 3 minus low bound value is 0. So what is the value? 1000 plus 1 into 3 minus 0 is 3. Hence the location of A of 3 is 1003. Check whether it is correct or not. So the address of the element 40 is 1003. See, if I want to find the location of A of 4, then what I have to do? What is the value of base of A? Base address, that is the first element address in an array, is 1000 plus the value of W is 1. P, the value of P is 4 minus LB. What is the value of LB? 0. So 1000 plus 1 into 4. 1004. Hence the value of location A of 4 is 1004. Is it correct? So this is how we are going to represent one-dimensional array in memory, as well as finding the address of the element in an array. In the last class, we have studied about the basic operations of one-dimensional array, isn't it? What are the basic operations of one-dimensional array? Basic operations of one-dimensional array. So what are the operations we can perform? First one is traversal. Second one is searching. Third one is sorting. Fourth one is insertion. Fifth one is deletion. And sixth one is merging. So these are all the basic operations which we can perform on one-dimensional array. So in this session we are going to study in detail about these operations. So the first operation is traversal operation. So what is the meaning of traversal? Traversal is nothing but the process of visiting each element of an array from the beginning till the end exactly once is called as traversal. See here, this array contains 4 elements. So what I am going to do? I am going to visit each element of an array exactly once. From beginning till the end of an array is called as traversal. See, first I am going to visit this first element. Next, second location of an element. Next, third as well as fourth. The process of visiting each element of an array exactly once from beginning till the end is called as traversal. So now we are going to write an algorithm for this traversal. So this is a 3-mark question. So this is a 3-mark question. So here let A be the array name. So here the name of an array is A. Then LB is the lower bound. LB is the lower bound of an array. And UB is the upper bound of an array. See, A is the array name and this is the lower bound and this is the upper bound of an array. So what is the first step? And we require location, because we are visiting each location of an element exactly once. So LOC is the location of an element. So what is the first step? First step is to visit each element of an array. We are using for loop, that is for location is equal to. So it starts from lower bound to the upper bound of an array. Hence location is equal to lower bound to upper bound. Step 2. What is step 2? Process A of location. Process A of location. By visiting each element of an array, that is each location of the element in an array, we are processing the location. We are visiting each element of an array exactly once. So here, end of for loop. What is step 3? After visiting each location of an element, so it is going to exit. So this is about traversing. Next basic operation is searching. Next basic operation is searching. So what is searching? Searching is nothing but the process of finding the location of an element in a linear array is called as searching. There are two types of searching: linear search and binary search. So in this session we are going to study about the linear search. Yes, what is linear search? Linear search is nothing but the elements are arranged in a consecutive memory locations. So in linear search, what we are going to do, we are going to find the location of an element in an array by comparing the search element with all the other elements in an array one by one is called as linear search. So now let's see how to find the location of an element using linear search. So this linear search is also called as sequential search. It is also called as sequential search because we are comparing the search element with all the other elements in an array one by one is called as sequential search. Consider an array containing the elements (14, 32, 6, 45 and 98). Trace the linear search algorithm to find the location of the element 45. Now what we are going to do? So we are going to find the location of the element 45. So what is our array? So our array contains 14, 32, 6, 45 and 98. Right. Yes. So always the comparison starts from the first element of an array. So value of I is 0. Value of I is 0. Here what we are doing? We are comparing 14 with the search element 45. So 14, here 14 does not is equal to 45. So hence I gets increment. We are going to search with the next element of an array. So I gets increment 14, 32, 6, 45 and 98. So here I gets increment, the value of I is 1. So we are comparing with the next element of an array. So what is the value of next element? 32. So is 32 equal to 45? No, 32 does not equal to 45. Hence I gets increment. 14, 32, 6, 45 and 98. Yes. Now I gets increment. What is the value of I? The value of I is 2. So here I am comparing with A of 2. So A of 2 contains element 6. So is 6 equal to 45? No, 6 does not equal to 45. Hence I gets increment. 14, 32, 6, 45 and 98. Now I becomes 3. Right. I am comparing 45 with the search element. So the search element value is 45. Hence 45 is equal to 45. Hence 45 is found in location 3. Hence 45 is found in location 3. So this is how we are going to find the location of an element using linear search algorithm. So now let's try to write an algorithm for linear search. This is your 5-mark question in your exam. Algorithm for linear search. So what is the first thing? Before starting comparing the element, so the location is -1. Next, in step 2, it starts comparison from first element of an array till the last element of the array. Hence, we are going to use for loop. For P is nothing but the location of an element. For P is equal to 0 to n minus 1. For P is equal to 0 to n minus 1. If element is equal to A of P. If element is equal to A of position. If the search element is equal to A of position, then the location will be P. Then the location will be the position. So go to step 3. End of if, end of for loop. What is step 3? Step 3, if location is greater than 0, what we have to do? If the location is greater than 0, we have to print the location. We have to print the location of an element. Else, what we have to print? We have to print that it is an unsuccessful search. Step 4, exit. So in linear search, the search starts from beginning, that is lower bound to upper bound. Hence, for P is equal to 0 to n minus 1. If element, the search element is equal to A of P, then location will be the P. Next, go to step 4. If the location is greater than is equal to 0, then we have to print the location of an element, else we have to print it as unsuccessful search. So this is the algorithm for linear search. Now, let us try to write a program to find the frequency of presence of an element in an array using class. So what is frequency of presence of an array? See, for an example, if an array contains 10, 50, 20, 30 and 10. So this array contains 10, 50, 20, 30 and 10. So here how many times this element 10 is present? That is 2 times. So that is what we are exactly going to find. The frequency of presence of an element in an array. So always the program starts with #include iostream.h. So why we are going to use this header file? So this header file is used to invoke the commonly used functions like cout and scene, which is required for our program. Next is #include conio.h. So this header file is used to declare the commonly used library functions for performing console input output operations for our program. Yes. Next, what we have to do? We have to define a class. So how to define a class? It always starts with the keyword class. It always starts with the keyword class. Then use a defined name. So what is the name of the class? I will consider it as frequency. The name of the class is frequency. Next, I am going to declare some variables in the private section. So why I am declaring it in the private section? The variables which are declared in the private section can only be accessible to the member functions, which is declared only within the class. Private int a of 10 n element and count. So these are the variables which are required in our program. Next, public. In the public section, I am going to declare the member functions. So what are the member functions we require? That is void get data. So get data function is used to accept the values from the user. And next function is void compute. So this compute function is used to perform the required operations. Next, void display. So this void display function is used to display the output to the user. Next, what I am going to do? I am going to close the class with semicolon. So this semicolon indicates the end of the class. Now, next what I am going to do? I am going to define the member function outside the class. So how to define the member function outside the class? Using the scope resolution operator. First I have to write the return type specifier. So return type specifier would be void. Void. What is the name of the class? The name of the class is frequency. Void frequency scope resolution operator. Next, get data. So the scope resolution operator tells that for which class this function is going to belong. So that is the usage of scope resolution operator. So get data. Yes. Now what are all the things we have to accept from the user? First thing is we have to accept the number of elements in an array. Enter the number of elements. Using scene, we are going to accept the values. M. Next, cout, enter the array elements. For I is equal to 0, I less than n, I plus plus. Cn A of I. Next, we have to accept the search element. So, cout, enter the search element. Cin element. I am going to close this function. Next what I have to do? I have to define the next function, that is compute. Void frequency, scope resolution operator, then compute function. So in the compute function, what we have to do? We have to write the code to perform the required operations. Count is equal to 0. As we have to traverse an array, so we are using for loop. For I is equal to 0, int I is equal to 0, I less than n, I plus plus, if element is equal to a of I, then count gets increment. See, in this example, 10, 50, 30, 40 and 10. So usually first what I am going to do, I am going to compare it with the first element. So element is equal to Fi. Our search element is 10. Right. So 10 is equal to 10. Hence count gets increment. So the value of count becomes 1. Next I am going to compare with the second element of an array. So 50 does not equal to 10, hence count remains same. Next I am going to compare with the third element of an array. So 30 does not equal to 10, hence count remains same. Next I am going to compare with the fourth element of an array. 40 does not equal to 10, hence count remains same. Next I am going to compare it with the fifth element of an array, so that is 10. 10 is equal to 10, hence count gets increment. So that is what I have written here. Now I am going to display the output to the user. Void frequency display function. Right. So what are the things we are going to display here? We are going to display if count is greater than 0, we have to print that frequency of element is count, else cout element is not found. Next, in the main function, we are going to create the objects of the class frequency. So how to create the objects of the class? First we have to write the name of the class, then object name, that is F. So now I am going to call all the member functions of the class frequency. So how to call the functions? Using the objects, I am going to call the member functions. So F dot object dot member function. So the first member function is get data, and next second function is compute, and third function is f dot display. So this is our program to find the frequency of a presence of the element in an array. Thank you.